So now next what? So this is how we define a function. So the first question is, we've answered that. The next question is that, so remember we define it like we denote it by an, okay? So next question is that, okay, what is the function? Next question is that we are interested in what? We are interested in the long-term behavior, okay? So the question number two is that mathematicians thought that, okay, how to define a long-term behavior? What we are interested in. So they wanted to find, so essentially this is how um, things evolve in science, okay? It's either experiment to abstraction. So 80% of the time it happens, experiment to abstraction. So what is experiment to abstraction? This is like abstractions or law or theory, okay? So if you see all throughout the history of science, this is has been the only guiding, 80% of the time it happens. Otherwise, like they predict something like this from here. For example, this was done, it's very hard. This was done by Ramanujan thing. So Ramanujan's mock theta functions were predictions of black holes, and that's what are used now. So these are hard to do. Okay, this is not easy, but this is how we learn. We observe from nature, or we get experiments. We see examples, and then we get theories. So can someone tell me what are the experiments in mathematics? What are the experiments in mathematics? This is something important to know from a philosophical point of view, because you understand. What are experiments in mathematics? Can someone tell me? Okay. So experiments in mathematics is nothing but playing with numbers and seeing the pattern. This is what the experiment in mathematics is all about. So what they did is was they were trying to understand the limiting behavior, so to see examples. So that you see that if you take f of n to be 1 by n, it was going towards 0, it was going approaching 0, okay? If you even draw it, you will see it's approaching 0. So they don't understand that, okay, so what is the meaning of this approaching 0? So they called it limit. So the question is that, how do you define a limit? Limit of a function, of a sequence. So okay, so let's try out with this example. So essentially the basic idea is this. Understand this term very well. The basic idea is this, that we are given f of n or an. The basic idea is this, that as n increases, I'm writing in code language so that it's short. As n increases, n should be getting closer to its limit. Now let's see where the mathematics can come in, which link, which words can focus on the mathematics. So that is getting closure, this part, the an part, as n increases, this part, and this limit. So let's call it limit L. We need to say getting closure, we will see. So we will see what we are meaning by this. And the n is already defined, and n increases, we will see how we do it. Okay. So what they did is this. So they did that, they defined like this, that n is a sequence. It goes to this, like its definition is this. That means, so understand there's a dynamics here, that something is approaching towards something, and something is getting, changing. Every single step, everything is changing. And that's the beauty of it. That's the dynamics of the whole definition. That something is changing every single time. So what's that changing thing? So we are trying to understand that. So as n increases, okay, as n increases, so we cannot define like this, that as n increases, let's say as n increases, we cannot say the distance so how we can define it? We can say that an minus l, this is the distance, right, between an and l, or let's say the modulus of it. This must go to 0. But again, the question must come that what does this mean? Like going to 0, essentially the same concept. So mean, like, question is that an going to l is equivalent to us saying that an minus l is going to 0, right? So the question is that what is meant, like we cannot be, it's a round circular argument, right? So we need to do it in a different way. So what they did is the following. They brought a dynamics to it. How did they do it? Is that, so understand there are two things. One is n is also increasing and the distance is also in a distance is decreasing. Okay. So what they did is that they fixed a certain distance. So what they did is the following. So they did that for all epsilon. So sorry. So it's like they fix an epsilon. They fix an epsilon. The epsilon is nothing but a strip of length around the limit. The fixed epsilon, and what they did is that they told that there exists, for this epsilon, there exists an n epsilon, like certain integer, certain natural number. This natural number is nothing but the index. It will show that n is increasing. Okay, belong to natural number such that, so in some sense, what they're doing is that they're fixing the entire thing. Each definition, this dynamics, they're fixing in every single step, and they're it's like if you have done computer science, it's like they're fixing every dynamics. If you're trying to run a for loop, it's like they're fixing every step and then they're running a for loop. It's like similarly like that. Okay, you will see that. So they're fixing epsilon, and they're saying that for that epsilon there is an epsilon, like a natural number, such that for all elements of the for all indices after n epsilon, the distance between the value of an and l is less than epsilon. So what they're doing is that, let's say a sequence is going like this. Going to 0 like this. We'll learn about this called oscillatory sequence. An example of such function is sine n by n. This is an important example in something called physics called damping. Okay. Also, it's like e to the power, yeah, damping. It's like damping is a very important aspect. Sine n is the waveform, and or you can say sine n by e to the power n. Also, some similar examples. Anyways, coming back to, so what the results, you can understand 0 is the limit. So L is equal to 0. The first step, see here. So what then you're fixing an epsilon. So what it means that, so what this means, you can also write this as alternately as an less than L plus epsilon and greater than L minus epsilon. So what they're doing is that they're fixing an epsilon length around L. This length is epsilon, this length is epsilon. Okay. I will do is the following. I will. Now what they're doing is that they're saying, okay, let's fix this and let's fix the epsilon length. Now for this epsilon length, there will be an epsilon. Let's say this one. So let me mark each of them individually. Let's say this one is this one is the red. So what's the red one? The n epsilon here, if you just draw it, if you just draw this whole, probably you can see that after, if you draw this whole strip, that means this strip is nothing but saying that L plus epsilon and L minus epsilon. So if you draw this strip, like the statement is saying that there exists an n epsilon. So you can see probably this is the n epsilon. Such that after this point, all the sequential points, all the an values, this is not the an values, right? Each of them is the an values. After all this an, all the an values lies inside this strip. Essentially, this is the basic idea. Now, what it's saying is that if this happens for all epsilon greater than 0, that means however small you make this, okay, still it should happen. I mean, then epsilon will change. Okay, then epsilon will change if you make it smaller. It will probably go to here next. But after that point, it will be happening. So what will happen if it does not happen? It's very simple. That means if it does not follow this, what will happen? That means for whatever epsilon you take, there always for whatever epsilon you take, there is always a point outside the strip. There's always a point outside the strip. So therefore, what happens? It will probably not converge. For whatever epsilon you take, it's probably always has a point outside that strip. So it will not converge. Always outside the strip, erratic. So it will not converge. You will not. It does not make sense that the values are getting closer and closer and closer. You understand? That's the basic idea. All of you understood this? I will share more examples. But did you understand? Yeah, Meenakshi.
My doubt is every sequence should have limits, either it is a convergence or divergence, or doesn't converge or diverge. Every sequence should have a limit, sir.
No, I will give more examples on that, Meenakshi. But let's
Okay.
say I will give more examples. But let's say you have a function. If you have a n that is going towards this L, I will share more examples. Let me show this to you via an animation. Uh, can you see it? Great. So it's developed by the University of Melbourne School of Mathematics and Statistics. So let's say these are two sequences, okay? These are two sequences. And you have taken epsilon to be this. Let's for sure. The m is nothing but the n epsilon here, okay? So for all epsilon greater than 0, there exists such an m, so that after that m, the fn, the sequence lies inside that strip, right? So for this fn, whatever this fn is, forget the second sequence, whatever this fn is, observe that for this epsilon, after this point, I should say, so let's say you take this epsilon to be this. Whatever the epsilon, this is a sequence. See, after this point, all the sequences greater than or equal to the same, all the sequence lies inside this strip. Right now, you change epsilon. This is outside the strip now, so you have to change it back here. After all these points, after this m is nothing but an epsilon. If you change this epsilon, see, this will go to this. Like if you take this m, then it will not happening. You have to take after this m. Okay. After this m greater than or equal to this m, all of them are lying inside this. So the smaller you make, you see these are all outside. So the smaller epsilon you make, there will be an m which is farther away. Okay. That gives an increasing idea of the sequence. After this, which is everything lies lying inside. Okay. Now let's take an example of sine of n. I don't know if it works or not. Yeah, this is the sine of n. Now you see the limit is now probably it's around 0. So whatever the limit you take, let's take this epsilon. Now see, whatever you take, there's always a point you will see that is outside the strip. Whatever, however large epsilon you take, not large, but however small epsilon you take, you will see always a point outside this strip. Okay, always a point. But you can prove, you will see that we can prove that it's nothing like there is no m. Of course, you have to see on the other hand side. We can zoom out probably. You can see like this. We have zoomed out. So it's a erratic. Essentially, however epsilon you take, whatever epsilon you take, there will always be a point. However large m you take, there will always be a point after that m which is lying outside that strip for every epsilon. That means for a certain epsilon. Okay, that means it's not converging. It's not going like the idea is that the strip idea is nothing but it's telling you that it's like going towards that. Okay, so because an minus l is its modulus is nothing but a distance between an and l, and it's going less and less as the epsilon is going towards 0. All of you understood this, yes or no? If yes, write yes or react. So the basic is the n epsilon is dependent upon the epsilon value. Okay, that is very important. Okay, any doubts? Please raise your hand. Okay, that's great. Let me come back to the. So now, so we have understood the basic idea of how the sequence is going, towards like what's the meaning of that. That's great. Now, okay, so we understood how to define it, but there are some issues to it that for a given sequence we have to know the limit L beforehand. See, this was developed when they applied it on known things. Okay, great. So we will see a method in the future called Cauchy sequence where we don't need the limit definition. That's why that Cauchy sequence was defined, because limit if we don't if we may not know the limit, it's going to be a bad function. Okay, so Cauchy sequence really helps in that time. Okay, so given that you understood that our goal is to find a limit, and how do we find the limit, and what is the meaning of the convergence? Okay, to a certain limit. So let's also talk about divergence now. Like divergence to plus infinity or minus infinity. It's very simple. Let's talk about plus infinity. It's very simple. What is infinity? Can someone define infinity? Okay. So infinity is nothing but an object, mathematical object. You can not call it a number. It's not a number because infinity isn't valid like the largest number. You're right, Anand. So it's not a number, but because it doesn't follow the the arithmetic numbers we saw that on the first day, right? Infinity plus one is not infinity. Something different. I understand. So infinity plus one is infinity. So therefore, it doesn't it's not a number. It doesn't behave like a number. Infinity is a different object of its own. But you can say infinity is nothing but anything. Infinity is a mathematical object which can be attached to a real extended real number line. Like you can attach infinity to a real number, such that it's greater than any real number, the largest possible number, not number, or mathematical like object. You can say largest possible, like any mathematical object that is larger than any real number. That is infinity. So that is essentially reflected over here too. So for all epsilon greater than 0, there exists an epsilon. So an epsilon is a bound after which it happens, such that an is greater than, not for all epsilon, for all real number greater than 0. N is greater than L for all n greater than equal to epsilon. Will be R. This is like a selection of that point. This is like after that, whatever happens, okay? This one. And this is like the point after which it happens. So you understood? This is essentially it's coming up. That n is greater than L. So I hope you understood this. I mean, it's not hard to understand before, after if you understood the previous one. But something I observed weird over here, a weird observation. I'll tell you the weird observation, but let's do an example first. Example. Example is, let's do an example. Let's do two examples. Fn is equal to 1 by n and Fn is equal to sin n by n. Okay. We have seen both of them are going to 0, right? So it goes, so we know the limit. So let's try to, so therefore what you have to show, you have to fix an epsilon. That's the first step. Then take the format like this is the step of the proof. Take mod an minus L less than epsilon, this quantity. So write it down properly in terms of the function, which turns out 1 by n less than epsilon. Now what you do is simple. You take epsilon, you get epsilon greater than 1 by n, right? Or sorry, n greater than 1 by epsilon. So observe, for this happens when this like implies, that means this is happening. That means for sure, I mean it means that not only like, it does not mean that if n is less than 1 by epsilon this will not happen. It means that if this happens, for sure 100% this is happening, this one. And this gives an idea of the n epsilon here, that for this to happen, so we want what, for epsilon fixed, we want an n epsilon such that this happens for all n greater than that. So this is the n epsilon, for all n greater than that it's happening, this one is happening. That's like what, it's like a reverse way of finding it, reverse engineering. So finding the limit is a reverse engineering method, like finding the proof. And therefore what do we see, that we get n epsilon to be n greater than this. So let's take the upper bound of this, like the greater like ceiling function. For n greater than n epsilon greater than equal to this, observe that n minus L, that is 1 minus n minus 0 is less than epsilon. So therefore the goal of yours is nothing but to find n epsilon. That's the goal. Okay, that's the goal, finding the n epsilon. All of you understood this example? Yes or no? Please react. If you didn't, then please raise your hand. I will help you out to understand. Make you understand. Okay, Prashant and Meenakshi, please tell me what's your doubt.
Sir, how does the mod
Can
is
you
a
please
and
explain
minus?
this example again?
Okay, one by one. Let's go to Prashant first. Yeah, Prashant, I will come to Meenakshi next. Yeah.
Sir, can you please explain this example again? Example one. Sir,
Okay, which
where
step didn't you understand?
NE,
This one, this
sir,
one, this one.
sir, from NE, sir,
In
N
epsilon.
epsilon. Yes, sir.
So understand that we want to find an in epsilon. Like it may not be a strict bound, okay? It can be any loose bound also. Like if this n epsilon works, of course this n epsilon also works, right?
Yes, sir.
So you don't find a strict bound. So essentially it's saying that agar like for this to exist, for this limit, for this expression to happen, for that n to be lying inside that strip, it's by calculation we are finding that n must be greater than 1 by epsilon, right?
Okay,
For
sir.
that to happen. So what we are getting? So therefore, if we fix the one in epsilon, like let's say epsilon to be 0.01, so we'll get that n must be greater than 1 by 100. So 1 by 0.01, that is 100. That means for this corresponding epsilon is equal to 0.01, n epsilon become 100, right? So what is the
Yes.
that's why I wrote n epsilon, because it's a function of epsilon. So as you change epsilon, the n epsilon will change. So it's telling you that for that n epsilon, this an minus l will be less than epsilon, and hence we have found out, right? We have fixed an epsilon, we have found an epsilon such that for 1 greater than equal to n epsilon, an is less than that. Did you understand?
Uh,
So then
yes, sir.
epsilon is nothing but the upper bound. Let's say if epsilon is equal to 0.12, for that 1 by n epsilon, 1 by epsilon will not be a of integer. So the ceiling function is taken to be make it an integer, okay, upper integer, because n is greater than that. Let's say if you do 1 by 0. Let me calculate 1 by 0.12, you will get 8.33. So you take n epsilon to be 9, the upper ceiling. I hope you know about the upper ceiling function. Yeah, Prashant. Hello. You are on mute, probably. Okay. Anyways, so coming back to Meenakshi, what's your doubt, Meenakshi?
Sir, how does the modulus function turns into the function of 1 by n, sir? An minus L turns out to 1 by n in the next step, right, sir?
I didn't get your question. So fn is equal to 1 by n, right? So this is equal to an, right? And L is equal to 0. We have assumed that. I mean, we know that, right? We have to prove that. So this turns out to be 1 by epsilon, right? 1 by n.
That is that. How to find the limit, sir? Is that an assumption or is
Yeah,
that
the
the
limit
theory
is the
behind the
assumption.
finding limit?
That's the thing. We have assumed the limit is 0. So that's the shortcoming of this definition, that it assumes the limit is without, like, it's assumed the limit is 0, okay? Like, it assumes that the limit is L here. Without knowing the limit, you cannot find this. It assumes.
Okay, sir. Sir, another doubt is in the previous illustration, what will happen if we increase the epsilon, sir? You have shown an illustration right now, sir.
Yeah, so increasing the epsilon doesn't make sense for convergence, because you're only interested in, because increasing the epsilon, if you increase the epsilon large, like like you will get all, you can get n equal to 1, like n epsilon equal to 1, because all the points will be lying inside that bound. So she's really interested in when we are going closure and making the strip smaller around the limit, whether all the points are lying inside that strip or not. Does it make sense? The increase
Yes,
in
sir.
epsilon, as I have told, increase in epsilon width is not it doesn't give a long-term behavior understanding. So decreasing it gives a long-term behavior understanding. Okay, that's the
Yes, sir.
basic
Yes,
idea.
sir. Thank you.
Yeah, my pleasure. So fn is equal to sine n by n now. So if it's sine n by n, let's try to do it. Let's fix epsilon. So let's write an minus l is less than epsilon. Let's write sine n by n is less, its mod is less than epsilon. And from there we got, so we have to find like this. Now this is where the issue comes in. So we have to find that n is greater than something. We have to find this quantity which is a function of epsilon. And this becomes hard. This is not possible. Even if you do it for 1 by n square, this will turn out to be hard. 1 by n square less than epsilon. So 1 by n square less than epsilon means n is less than root epsilon and greater than minus root epsilon. So it's becoming hard to find it out more. Sorry, 1 by n, I should say. So yeah, you can just remove this and you can say n is greater than 1 by root epsilon. But the basic idea is this, that for complicated functions, for complicated functions, even if we know the limit L, which is not probable, which is not easy to find, then finding n epsilon is a hill of a job.